welcome to this video lecture. This is Mark Scythian, FAA licensed aerospace technician, airframe, power plant, and avionics certified. The date today is December 31st, 2017. In this video lecture, we're going to cover how to graph quadratic equations in vertex form. Leaving off from the previous quadratic equations lecture, we had calculated or converted the given quadratic equation in standard form to vertex form. Now we're going to take this given vertex form quadratic equation and graph it. So let me go ahead and copy that vertex form quadratic equation, and we'll verify we have the correct data. 5x are 5 parentheses x plus 7/5 quantity closed squared minus 1/69 is equal to 0. So verify if that's correct. 5 parentheses x plus 7/5 squared minus 1/69 equals 0. Okay, we got all the data. So the mechanics of this vertex form quadratic equation are such that this would be the d variable, or the d value, and this is the e value. So the h, of course, if we define the parabola of, this is the graph of all quadratic equations are a parabola. So let's say it was something like this. The vertex would be that middle point half section of the parabola. The y-intercept would be where the parabola meets the y-axis, and the x's, or the zeros, would be where the parabola meets the x-axis. So here's the x-axis and here's the y-axis. So that's the mechanics of the graph of the equation in vertex form. So to know where the vertex is, the x, y coordinates, the location of the vertex is represented by h, comma, k. This would be the x coordinate location. This would be the y coordinate location. Of course, this graph is not correct to this given data here, because to get the h, you would have to take the opposite sign of d. So that would be negative 7/5 for the h. Negative 7/5 for the x coordinate. So you'd have to go back negative 1.4. And then the k is equal to the e without changing any sign. So minus 1/69. So that's the location of the vertex. So you'd have to go back negative 1/69. If you get a calculator out and put it in decimal form, that's negative 33.8. So you'd have to go negative 1.4x and then negative 33.8y. So it'd be something like right here. That would be the vertex point. So we'll draw another grid here. So we've established quickly where the vertex point is. Negative 7/5, comma, negative 169/5. That's the vertex point. The x's, as we calculated in the first quadratic equations lecture using the quadratic formula, the x's, or the 0 points on the graph, the zeros they call it, is 6/5 and negative 4 respectively. So that represents, so we have x for this given quadratic equation, the x's, x values, also known as zeros, will equal, x is equal to 6/5 and x is equal to negative 4. So those represent where the parabola will meet the x-axis. Remember, this is the x-axis, this is the y-axis. So let's say that's -4, and 6/5 is 1.2. So 6/5 might be like right here. Positive 6/5, -4, right? So that was where the parabola will cross the x-axis. And then the vertex point, remember, -7/5, -1.4, and then minus 33.8. So let's say 35 is right here. So the vertex point would be like right here. And then we calculated the to get the y-intercept, we just take the original standard form quadratic equation. Just write that back out. So 5x squared plus 14x minus 24 is equal to 0. So instead of equaling it to 0, we rewrite this as y is equal to 5x squared plus 14x minus 24. And then we substitute all the x's with 0. And of course, 5 times 0 squared is 0. 14 times 0 is 0. So you're left with the y-intercept of minus 24 is the y-intercept. So let's just say minus 24 is like right here on the y-axis. So that's where the graph will meet the y-intercept. So now you can just sit there, and if they ask you to sketch it, you can sketch it pretty easily. It'll be like something like this. I can't, it's hard to do it symmetrically. Because remember, this is not art, this is finding mathematical input-output functions. So it'd be something like this. That's how your graph would be. Oh, let's just say that is where your vertex is. HK, which is -7/5, comma, -169/5. This is your y-intercept, -24, and then your zeros or your x's are -7. It'd be x. So put -4, 6/5. And so very quickly you've graphed this, looking at these variables or these values in the vertex form quadratic equation. So the d is the h in negative sign. So what would the h be here? -7/5. What would be the k? -169/5. Where are the zeros? So we calculated 6/5 at -4. And what is the y-intercept? You can use that method. Just equal the quadratic equation to 0, or and to equal the quadratic equation to y instead of 0, and then enter in 0 for the x's to get the y-intercept. Very simple, very easy. And if you use this technique, you'll always be able to zip through all of the quadratic equation graphing problems that you're experiencing. So thanks for watching this video, and have a great day.